So we have x equals 2, and I'm going to substitute in that in the first equation, 12 times 2 plus 3y equals 21. 24 plus 3y equals 21. I'm going to subtract 24 from both sides. 3y equals negative 3. Divide both sides by 3, and y equals negative 1. Now I have an x value of 2 and a y value of negative 1, so I'm going to write it as a point 2, negative 1. What do you notice about your solutions for part A and B? Well, they both are 2, negative 1. 2, negative 1. So our solutions, they are the same. What that means is you can solve by eliminating the x variable, or you can solve by eliminating the y variable, and you will get the same solution if you solve it correctly. For number 2, solve each system of linear equations by using elimination. So we're trained to do substitution, but now we're going to try elimination. Is there something I can multiply this 1 by to get to 5, or the 5 to get to 1? I would have to multiply this first equation by negative 5 if I want to do elimination. Remember, elimination, we want to get them to have the same coefficient, but one negative and one positive so that it gets eliminated. So this top equation needs to have a negative 5x. I could have also chosen to eliminate the y's. That would have worked as well. But I'm going to stick with this. Multiply everything by negative 5. Negative 5x minus 10y equals negative 75. And I keep this bottom equation. 5x plus y equals 21. I'm going to do elimination and add those equations together. I have negative 5x plus 5x, 0x. Those are eliminated. Then I have negative 10y plus y. I'm left with a negative 9y. And then I have negative 75 plus 21. And I end up with a negative 54. To get y alone, I divide out negative 9. And y ends up being positive 6. Now that I know that y is positive 6, I'm going to substitute that into either equation. I'm going to use the second one because y is alone here. So 5x plus y equals 21, and y is 6. So that's going to be substituted in as y here. 5x plus 6 equals 21. Subtract 6 from both sides. And 5x equals 15. I'm going to divide out 5 from both sides to get x completely alone, and x is 3. I write my answer as a 0.36. So when we do elimination, we have to multiply to get them to have the same coefficient, one positive and one negative, so that they can actually cancel out and be eliminated. Once we get one variable, we use substitution and substitute it into another equation and solve for the other variable. Then we write our answer as a point. Let's try number 3. Let's say I want to eliminate the y's this time. I have a positive 2 and a negative 4. So I need this top equation to be a positive 4 if I'm going to add it to this one and get 0y. So in order to get this to be a positive 4y, I need to multiply this whole top equation by 2. I end up with negative 6x distribute plus 4y equals negative 16. The bottom equation stays the same. 6x minus 4y equals negative 20. For elimination, I add those equations together. Negative 6x plus 6x, that's 0x. And 4y plus negative 4y, that's 0y. Now we were planning on eliminating the y's, but we also eliminated the x's. So those two equal negative 36, so really 0 equals negative 36. We know that statement is not true, so we get no solution. On our next page, number 4, Again, we're solving by elimination. So is there anything I can multiply 2 by to get to 3, or 3 to get to 2, or 3 to get to 4, or 4 to get to 3? We want them to have the same coefficient, remember. This one's going to be a little trickier because I can't multiply one equation by something and have it be the other. So let's work with the x's, because those numbers are a little smaller. I'm going to have to think of the least common multiple between 2 and 3. So that would actually be 6. So I need my top equation to end up with a positive 6x. My bottom equation to end up with a negative 6x. So what do I need to multiply them by to get there? This top equation I have a 2x right now, and it needs to end up being 6x. So I need to multiply this all by 3. So I have 3 times 2x is 6x. 3 times negative 3y is negative 9y. And 3 times 5 equals 15. The second equation already has a negative 3x, and it needed to be negative 6x. So I have to multiply the whole thing by 2. 2 times negative 3x is negative 6x. 2 times 4y is 8y. And 2 times negative 8 is negative 16. Now for elimination, I add these equations together. 6x minus 6x, 0x, that's exactly what I wanted. And then we have negative 9y plus 8y is a negative y equals 15 plus negative 16 is negative 1. I don't want to know what negative y is, I want to know what positive y is. So I'm going to multiply everything by negative 1. So y equals 1. Then I use substitution. Y is 1. I'm going to substitute that into an equation. 2x minus 3y equals 5. And y is 1. So 2x minus 3 times 1 equals 5. 2x minus 3 equals 5, and I'm going to need to add 3 to both sides to get those x's alone. So those equal 0, and I have 2x left on this side equals 8. 5 plus 3 is 8. I need to divide out 2 to get x completely alone, and x is 4. X is 4, y is 1, so I write my answer as a point, 4, 1. That is where these two lines intersect at 4, 1.